Welcome to Learn Elite Academic. Here we have a short live video today, and we are here to study the term density. That's our topic of today. And for we to study density, I would like to use water as our case study. Being that water is a matter. We know that matter is anything that has mass, that what occupies space. And matter, we all know that matter exists in three states: solid, liquid, and gas. These are the three phases of matter. But water, as matter, also exists in these three states. We have solid water. That is when we are talking about what? Solid water. We are talking about ice. Ice is solid. We call it solid water. We have what? Liquid water. The one we drink, cold water. And we still have what? A gaseous water, that is steam. These are the three states of water. But it has been observed that ice as water, which is the solid water, float on what? On liquid water. From an experiment, we have observed these things, and you know what I'm talking about. When you place ice and water together, you find out that the water will sink while the ice will be floating on top of the water. What is the cause? This is due to what? The fall of density. When water is in the solid state, which is ice, when water got frozen, the density of the water falls. The density of the water decreases. So in the solid phase of matter, of water, density what? Decreases. But in that state, volume what? Increases. So when we are talking about solid water, when we are talking about ice, why it floats on top of water is as a result, is because in that solid state, the density of the water has fallen, and the volume of the water, which is the ice, has what? Increased. It's vice versa. When we now come to liquid water, density now what? Increases. That is why you now say that the water now sink in the vessel. Are you getting now? So in that liquid state, density what? Increases. And volume decreases. But in solid state, density decreases. Volume increases. But in both states, mass remain what? Unchanged. Man never is not affected. Mass remain what? The same. The mass of water in that solid state is equal to the mass of water in that liquid what? State. Are you getting now? That is mass remain what? Unchanged. Now, when you look at this, from this our explanation, when you see that, when you say in that solid state, when we say in that solid state, density increase, volume decrease in both sides now. When density is increasing, volume is what? Decreasing. When volume is increasing, density is what? Decreasing. What does that have to tell us? Now, according to mathematics, when two quantities, when one is increasing and the other is decreasing, it shows that the two quantities varies inversely, one varies inversely as the other. That is what we mean. So in other words, from our explanation here, we cannot see that density, which is density, varies inversely as what? Volume. With mass constant. This is the mass. Mass constant. You see there. And the density of a substance, we denote it using this symbol. This is a symbol for density. Varies inversely as well volume, the symbol. We said that mass M is constant. This is what I'm saying. I'm only repeating it. Look at me. This is the symbol for density. This is the symbol for volume. And this is the mass is constant. So in other words, if I say density here, if I remove this symbol, proportionality sign, it will now become equal to K over what? V. Remember we said that K is mass. So in other words, I can say therefore, the density of substance now cannot be mass over what? Volume. We now have density to be this now. Where M there is the mass, V is the volume, and this symbol here, this Greek letter here, rho, is what? The density. Now, from this equation, we cannot define density as the mass per unit volume from what we are saying here now. We now see density as mass per unit what? Volume of a substance. So if somebody asks you, what is the density? What is density? We now say that density of a substance is the mass per unit what? Volume of the substance. And now, we now talk about the SI unit of density. What is the SI unit of density? Listen. The SI unit of density is kilogram. Kilogram per meter cube. This is it. This kilogram per meter cube. Or sometimes, we can still take it as gram per cm what? Cube. Because with what is here, when we say gram, listen to me. Now, the density of water, listen carefully. The density of water at 4 degrees Celsius, take note. The maximum density of water at 4 degrees Celsius is approximately what? 1000 kilogram per meter cube. Or we can say that is equal to 1 gram per cm what? Cube. That's the density of water. Because now, in liquid generally, mercury is the most denser what? Liquid. Mercury is the only liquid that is denser than water. Because the density of mercury is 30,600 what? Kilogram per meter what? Cube. That is the density of what? Mercury. Or we can say that is 0.6 gram per cm cube. You see now, this is the density of mercury. Look at the density of water. So the only liquid that is denser than water is what? Mercury. Always take note of that. Now, I want you to understand one thing about this unit of density. When we say we have 1 gram per cm cube, when you have something like this, what are we saying? We are saying that 1 gram over what? This is cm cube versus cm what? Cube. Look at what we are saying. Are you getting it? Now, this is 1 gram over what? This. And what is it? What do we mean by 1 gram? Now, like I said, what we have discussed so far, like as I was talking about the density, I said that 1 gram per cm cube, take note, is equal to 1 gram per centimeter cube like this. But I want you to know, when we say 1 centimeter, listen carefully, 1 centimeter, when we are talking about centimeter cube, like 1 centimeter cube like this, it becomes what? Look at me. In this case now, 1 gram become 1 times 10 raised to power minus 3. Divide this now is 10 raised to power minus 6. That's what it stands for. And here now is in kilogram. We are converting to kilogram per meter cube now. Look at it. Are you getting that from here now? You see? So in other words, we cannot say that here now we have 10 minus 3 plus 6. It becomes 10 raised to the power 3 kilogram per meter what cube. So from here now we have it as 10 raised to the power 3 kilogram per meter what cube. So I want you to understand when they say 1 gram per cm cube is equivalent to this, which is 1000 kilogram per meter what cube. Now, from this equation here now, equation I've given to you so far about density, mass over volume. Now, we want to resolve this equation. These questions here. Let's use the equation now. How do we make use of this equation? Now, as you can see now, examiner can give you questions like this just to test you. Now, how do we come about it? Like example 1 here now, you look at it. It said a body whose mass is this and has a volume of this just float when completely immersed in a liquid. Calculate the density of the liquid. Now, if you look at it very well, they gave you the mass of the body. Solution. They gave you mass as 2 kg. It's 2 kg. They gave you volume as 500 cm what cube. They gave you something like this. Now, if you look at this unit, here is in kilogram. Here is cm cube. But remember I gave you the unit of density. I said that density, we are either measuring with this or gram per cm what cube. If you look at these two units, this one is kilogram per meter cube, this one is gram per cm cube. But if you come here and you have kilogram, you have cm cube. Yes, cm cube here. Now, it shows that one of them need to be converted for one. There must be a conversion done here. How do we convert? Which of them are we to convert? When you are in exam hall, you don't rush to convert. How do you know the one to convert? Go back to the equation, to the question. Now, go to the options of the question now. Now, in the question here, if you look at the option here, they gave it 4.0 times 10 raised to the power 2 kilogram per meter cube. So the options, they are in meter cube. Look at them. They are in meter cube. Since they are in meter cube, it shows that we are going to convert this cm cube to meter. We are going to convert this cm cube to what? To meter. But don't forget this. You must observe that 1 meter is equal to 100 centimeter. 1 meter is equal to 100 what? Centimeter. It means that 1 centimeter will now be 1 divided by 100. Will now be 0.01 what? Meter. It becomes like this. You see now? So, in other words, that is for length, when you are measuring what? Length. But if it's for area, when we now say 1 meter square, what is it? It becomes 100 times 100, which is 10,000 centimeter square. 1 meter, 1 meter square, that is for area now. It becomes like this. 100 and 100 will give you this. So in other words, we cannot say that 1 centimeter square cannot be what? 0.0001 meter square. Are you getting it? It becomes like this. This is for what? Area, when you are dealing with area. But when we now come to volume, 1 meter cube is now 100 times 100 times 100, and that will give 1 million. 1 million cm what? Cube. It shows that our 1 cm cube will now be what? 0.00000 1, 2, 3, 4, 5, 6 will now be what? A meter what? Cube. This is now what? In volume. So 1 cm cube is equal to this. So this volume, for we to convert this volume now, when you come down now, you will now say that this volume, which is 500 cm cube, cannot be what? Because it becomes 500 times 1 cm cube. Look at it. This can be written as this. Which cannot, in this place of 1 cm cube, cannot be this. Which means that this statement you are seeing here, I mean 10 raised to the power minus 6 meter cube. That's what it stands for. In standard form, if you have to put this in standard form now, it will become like this. So if I come here, it will now be 500 times 10 raised to the power minus 6 meter what? Cube. What have I done? I've succeeded in converting this. You see now? So, in other words, for we to not get the density, I cannot say density cannot be what? Mass over what? Volume. What is a mass now? Mass is 2 kg. Divided by 500 times what? 0. Times 10 raised to the power minus 6. It becomes like this. Officially, this is 10 raised to the power minus 6 now. So we can say 2 times 10 raised to the power 6. It becomes 2 million. Because if we take this one upward, this minus will leave here according to indices. It will not be 2 million at the top. Divided by what? 500. So we say 2 million divided by 500. 0 cancel what? 0. Yet we got 20,000. And when you divide 20,000 by that, by 5, 20,000 by 5 becomes 4,000 kilogram per meter cube, or in standard form become 4.0 times 10 raised to the power 3 kilogram per meter what cube. What have we done now? In this case, listen carefully. In this case now, when you come here now, what is our option? Our correct answer is option B. Look at it here. Option B is our correct what? Answer. Just look at it. Option B, look at it here. This is the answer. Let me underline it. Look at it here. This is the answer there. Now, in this case, we have example 2 now. A block of wood of density this. This is the density of the block. Weighing this in air, which is the true weight of the block in air, float freely in a liquid of density this. Calculate the volume of the portion in air. Now, all you need to do here, we already know that we have the density of the wood. Density of wood is what? Is 0.6 gram per cm cube. Density of what? Liquid is 0.9 gram per cm cube. We now have what? The weight of the object in air. Weight in air is what? 3.06 what? Newton. Now, first of all, we are going to get what? The mass of the body now. And we all know that mass, when we say weight is equal to what? mg. We have it like this. Remember, acceleration due to gravity G is given to you as 10. Look at it here. It's given to you. So in order to what? We cannot say that therefore, listen, we said that weight now, we now say that mass is weight divided by what? Gravity, acceleration due to gravity, which is 3.06 divided by 10, and that will give 0.306 what? Kg. It will look like this. This becomes the mass of the wood. The mass of the wood. Are you getting now? Now, if we have this as the mass of the wood in air, take note. Remember, if you look at here is in kilogram, and here they are in gram. So if we say, from our question now, we have said that density, we said that 1 gram per cm cube is equal to 1,000 kilogram per meter cube. 1 gram per cm cube is equal to this. So for we to get the mass now, we cannot say that therefore mass, the mass now cannot be 0.306 times what? 1,000. From kilogram to gram now, we are converting to gram. We have to multiply by 1,000. And it will now be what? 306 gram. That is the mass in the air now. So then we cannot talk about the volume. But looking at the volume, we know that density is mass over volume. Therefore, volume cannot be mass over density. So in other words, we now say that volume here, what is the mass now? 306 divided by what? 0.9. We have it like this. Divided by 0.9. So when you divide and multiply this by 10 now, it becomes 3060 divided by what? 9. Multiply here by 10, multiply here by 10. It gives you this. So finally your answer becomes 340 what? Gram. 340 cm cube. It becomes like this. The correct option here now, if you look at it, is option what? Option B. Look at it here. It's option B. Look at it. It's 340 what? Cm cube. That is the volume. Now we are to continue from where we saw. Look at this. We are still on density. Look at it. Now, when we started now, I've given you this equation, and I told you that density is mass over volume. But remember, when we started, we were talking about ice, and when we're trying to describe water, solid water and liquid water, I made you to know that when water got frozen, we said that the density what? Decreases with increase in volume. That is, volume then what? Increase. With mass remaining what? Unchanged. Mass remain what? Constant. So if the mass remain constant, look at what I'm saying here. As the body is here now, look at this. We say that density is this now. In this case now, for mass to become constant, we cannot say that. Therefore, we say that mass is this. Mass cannot be written as this. Because the mass is constant, mass cannot be this. But remember this, I want you to get this noted. That if mass is equal to this, if mass is constant here, like we said before now. Now, if there's an increase in density, there will be decrease in what? In volume. For example, look at me. If I fill a cup, if this is a cup of what? Water. Look at me, this is a cup of water here. And there's a what? Is a kind of a ice, containing ice, frozen water inside. Listen carefully. When you contain the frozen water here, get this noted. When this water gets melted, listen, at this time, the density here, the density of ice, you know that in ice state, density what? Decreases. In solid state, which it is the density. Volume what? Increase if volume of ice. And remember, the mass here is the same. It's the same mass of water, whether solid or liquid. Now, when this water now get melted, this is now water, liquid water, this is liquid now. The density here, density of what? Water here. Here, volume of what? Water. Look at it. This ice, volume of water. Mass remain what? Is mass of water. You see now, so if I say here now, and I say this is mass of ice, let's say mass of ice, let's mass of water. At this time, they are equal. Because why? Mass of ice is equal to mass of what? Water. So in other words, if we say mass of ice is equal to mass of water, it shows that density of mass, what is mass? This is mass. Look at it, this is mass. If mass is density times volume, means that mass of ice becomes density of what? Ice, volume of ice equals to density of water, volume of water. From here we got this equation. Are you getting now? So we can have this equation, and this equation we can make use of it. So that we write it like this, or we can say that density of ice, density of water. When I say volume of water, volume of what? Ice. We can take it like this. We can write it in this format. We are discussing what? Density. Now, from what we have discussed so far, from the last equation I gave to you on density, now we want to use the equation to solve this example 3, example 4, and example 5. Let's look at them. Now, if you look at this example here, with what we have said so far, we find out that this example, we say, what volume of alcohol? Thank you. Now, what you are doing now, you are looking for volume of alcohol. Volume of what? Alcohol. Say what volume of alcohol? With a density of this, that is to say, density of alcohol is given as 8.4 times 10 raised to the power 2 kilogram per meter cube. We have the same mass as this of petrol. That is volume of petrol. Volume of petrol is what? Is 4.2 meter cube. That is volume of petrol. Whose density is this? Whose density is this? Now, density of what? Petrol is 7.2 times 10 raised to the power 2 kilogram per meter cube. So what we just need to do is this. According to the question here, we are saying now that mass of what? Mass of alcohol is equal to mass of petrol. That's what we are saying. You see now, say what volume of alcohol with a density of 8.4 times 10 raised to the power what? 2 kilogram per meter cube. We have the same mass as 4.2 meter cube of petrol whose density is 7.2 times 10 raised to power 2 kilogram per meter cube. Now this will say mass of alcohol is equal to mass of petrol. So therefore, we can say that density, mass of alcohol will not be density of alcohol, volume of alcohol. Or we say density of what? Petrol, volume of petrol. So in a case like this, what is the density of alcohol? Is 8.4 times 10 raised to power 2. Look at it here. Density of what? Alcohol. Volume of alcohol is unknown. We are looking for it. Times V. We have this. What about density of petrol? Density of petrol, we have 7.2 times 10 raised to power what? 2 times. The volume of petrol, what is it? 4.2. We have 4.2. We have it like that. So in other words, we are going to divide both sides using this 8.4 to divide both sides to make this the Sawyer formula. We now say volume of alcohol can now be what? 7.2 times 10 raised to power 2 times 4.2 divided by what? 8.4 times 10 raised to power 2. This can cancel this. We say that now. So if we cancel now, this times this now. When this cancel this is 2. This cancel this is 3.6 meter cube. That is the answer. So in other words, our correct answer here will be option word B. This is the correct answer. Option B. Look at it here. This is the answer now. I can underline it. Option word B. That's it. Now, from here, we want to look at example 4. The question is, said the change in volume when 450 kg of ice, mass of ice, 450 what? Kg. Look at it. That is the mass of ice. 450 what? Kg is completely melted. That is what they ask you to calculate and change the word, then change the volume. That's what we are looking for. Now they gave you the density of ice. Density of ice is 900 kilogram per meter cube. Density of water 1000 kilogram per meter cube. Look at this. Now the question is for you to calculate the change in word in volume. Now look at this now. Volume is not what? Given. But when we're discussing density, we said that density is equal to mass over what? Volume. Therefore, when I say volume is equal to what? What is it? Volume here becomes mass over what? Density. We take it like this. So from this formula here, I can look at it here. Look at me. I can come here now. I will now say, remember, mass of ice is equal to mass of water. Mass of ice is equal to what? Mass of water. Because when this ice melts, mass remains constant. So it shows that mass of ice is equal to mass of what? Water. So automatically I can say that density of ice here, volume of ice, density of water, volume of water, and you get it now, is equal to mass of ice equals to mass of water. They are all equal. Look at it. You see now? So in other words, I cannot say that mass of water is still the same as 450 kg as mass of ice. So in other words here, for me to go now, I will not say therefore volume of ice, mass over density. Volume of ice will not be mass of ice, will not be mass of ice over what? Density of ice. What is it? 450 divided by what? 900, which is 0.5 meter cube. Look at it. It's 0.5 what? Meter cube. 450 divided by 900 is 0.5. Now, when I say volume of water, what is it? It's now mass of water, which is equal to equivalent to mass of ice, density of water. 450 divided by what? 1000, which is 0.45 meter what? Cube. We have it like this. So in other words, when I say change in volume, look at me. Then change in volume, change in volume. We have it. Volume of what? Ice minus volume of water. You know, in solid state, volume increase. That's in metal state. So in other words, volume of ice is what? 0.5 minus 0.45. In other, we have it as 0.05. Check it. Look at it. We have it as 0.05. And at the end of the day, it will now be meter what? Cube. That's the answer. So the correct option here will be option what? Option A. Look at it here. This is the correct option. Now, alternatively, if I want to check it again, let's check it this way. Use this formula now. Using this formula, look at it. I can say density of ice is 900 times volume of ice. I can say 1000 density of water times volume of water is equal to 450. Because that is what? Mass of water is equal to mass of ice. So they are equal. Everything is equal to 450. In other words, from here, if I want to get the volume of water, look at it. I will say volume of water. I will use this 1000 to divide. Will now be 450 divided by 1000. And that will be what? 0.45 meter cube. Now, if I want to get the volume of ice, I will equate this to this now. Divide both sides by 900 now. We now say volume of ice is equal to 450 divided by what? 900. And that is 0.5 meter what? Cube. So if you say this minus this like we have done before, we now say change the volume. Change the volume. Volume of ice minus volume of water. Which is what? 0.5 minus 0.45. Which is 0.05 meter cube. Which is this. So this is another way you can see what? Go into it. This is how you can see solve it. Now, from here now, example 5. The density of 400 cm cube of palm oil is this. That is the initial density. Is this. So, before frying, that's what they said. That is initially. So, density, initial density is what? Is 0.9 what? Gram per cm what? Cube. Initial volume is 400 what? Cm what? Cube. That is what is given. Before frying. Now, they now said, he said, if the density of the oil was this, after frying, that is the final density, D2, is equal to 0.6 gram per cm cube after what? Frying. He now said V2 now is what? Say the questioner said, say after frying, assuming no loss of oil due to spilling, its new volume was, that's the question now. So now, all we're going to look at now, before frying and after frying are equal. So the density, mass before frying is M1. Mass after frying is the same thing. Mass remain constant. So in other words, the initial density, the mass here will now be initial density, initial volume equals to final density, final what? Volume. So what is here? Initial density is 0.9 before frying. Volume is 400. This one is what? 0.6, which is a final density times what? V what? 2. Divide both sides by 0.6. When I say therefore, V2 become what? 0.9 times 0.1 times 400. Divide by what? 0.6. And this will now land us to what? This divide, you divide now. This times this, 360. Divide, become 600 what? Meter what? Cube. It become like this. Cm cube, centimeter what? Cube. That is how it will be. 600 cm cube. That's what we will give you. So the correct option here will be option what? B here. Look at it. Which is 600 what? Cm cube. Now, I think this will be the end of our live class for today. But in our next class, we will be treating determination. We are going to be determining what? The density of irregular shape. That will be our next class. But nevertheless, try to comment. Click on the button as usual. Invite your friends. We have more for you. We are coming. God bless you.